Well, Streptococcus suis is a major bacterial pathogen in swine because it causes very severe invasive diseases like meningitis, septicemia, and arthritis, just to name few of the clinical signs that you may see after a Streptococcus suis infection. Due to this clinical manifestation, Strep suis causes significant economic losses to the swine industry.
Welcome to the Swine at Canada podcast show, brought to you by Wisnetics. We are dedicated to bringing you the latest insights and discussions in the Canadian pork industry. So my name is Miranda Smith, and I'll be hosting today's episode. And today's guest is Dr. Mariela Segura. So she is a full professor at the Faculty of Veterinary Medicine at the University of Montreal and the director of the Swine and Poultry Infectious Diseases Center, which is a strategic research network in Quebec. So she is also the holder of the Canada Research Chair in Immunoglycobiology of Infectious Diseases. So that's quite a mouthful. So welcome to the show, Mariela.
Thank you for the kind invitation, and I'm very happy to be with you for these few minutes and share some knowledge about Streptococcus suis.
Yeah, so today we'll be talking about Streptococcus suis vaccines, and especially like its progress and future challenges. So everyone, please sit back, get ready to expand your knowledge, and stay ahead with today's episode. So before we get started on talking about Streptococcus, Mariela, can you give us a little bit of background information on where you came from and like how you ended up in your current role?
Well, as you may guess, listening at my accent, I was born in Argentina, so I'm Spanish, and I studied microbiology there. And after I graduated, I obtained a fellowship from the Canada federal government, and I came here to Quebec in Canada to do my master degree, and I love it. I love science and research, so I found that it would be a great opportunity in terms of professional development. So I decided to stay, and then I did my PhD at the Faculty of Veterinary Medicine in microbiology, infectious disease, and focus on immunology, host pathogen interactions. And after my PhD, I did two postdoctoral trainings, one in Laval University in Quebec City, more on molecular pathogenesis of diseases and focus more on parasites, and then another postdoctoral training on host pathogen interactions again, but based more on parasitic disease in human. And then finally got a position as researcher and professor in immunology at the Faculty of Veterinary Medicine and moved back to my first love, bacterial diseases and Streptococcus suis.
Okay, perfect. And so that's what we'll be talking about today, Streptococcus suis. So, like, can you tell us a little bit, like, how significant is Streptococcus suis as a global threat to swine health and the pork industry?
Well, Streptococcus suis is a major bacterial pathogen in swine because it causes very severe invasive diseases like meningitis, septicemia, and arthritis, just to name few of the clinical signs that you may see after a Streptococcus suis infection. Due to this clinical manifestation, Strep suis causes significant economic losses to the swine industry. It is important to remark that the bacterial pathogen will mainly affect post-weaned piglets between 4 and 9 weeks of age. I would like to remark that Strep suis is responsible for about 1/3 of the antibiotics being used to treat bacterial diseases during the nursery period. So it's a huge concern about antimicrobial resistance, and not only because the use of antibiotic, but also because Strep suis is considered what we call a niche for antimicrobial resistant genes, which means the bacteria harbor a lot of genes causing resistance to antimicrobials, and the bacteria may spread those genes to other bacterial pathogens in the swine and in the environment. So why it's so important to reduce the use of antibiotics and also improve strategies to control Streptococcus suis. Another important issue about the Streptococcus suis is one of the most important bacterial infection observed in the presence of Pierce virus. What else? I guess another point that is important for people working in the swine industry is that the Strep suis is also zoonotic agent, which means it's capable of infecting humans. That means transmitting from swine to human. So it's affecting people working in close contact with pigs and posing a public health risk in certain areas or regions where the swine production is big. Actually, in Occident, Streptococcus suis is a zoonotic infection considered an occupational disease. However, in Asian countries and in East Asia, is the general population which is at risk due to cultural behavior like eating uncooked pork products. So in Occident, this will not happen, but in some Asian countries, it is a cultural behavior leading to several outbreaks of Streptococcus suis infections in humans.
Okay, so it's a pretty significant risk for both humans and animals by the sounds of that.
Yeah, that's right.
So then I guess the answer might be in vaccines. So can you talk a little bit about like the current vaccine landscape? Like what are some of the main types of vaccines that are currently available?
I will give you some context so we can understand then the landscape of vaccines. So one important thing to consider when we start thinking about vaccinations and vaccine development is that the Strep suis is covered by a sugar coat, which is known as capsule or capsular polysaccharide. It's kind of a big hat of sugars, that this capsule allows the bacterial classification into types, or better known by veterinarians as serotypes. With officially recognized 29 serotypes, the epidemiology of Strep suis is highly variable due to this serotype diversity. So this complicates control measures such as vaccination. It should be noted, however, that serotype 2 is one of the most frequently associated with clinical disease in both pigs and humans worldwide, and particularly in Europe, Asia, and North America. But there are other prevalent serotypes also clinically important, like, for example, serotype 7 and 9 in several areas or countries in Europe. So basically, in summary, the disease epidemiology is complicated by regional differences in virulence factors, heterogeneity of the strains, even within the same serotype, different serotypes causing clinical signs in different areas of the world. So, for example, it is well known that serotype 2 strains in Europe and Asia are phenotypically and genotypically different from those found in Canada and USA. So we need improved surveillance and we need improved vaccine strategies. This leads us to what is the current vaccine landscape? Well, it's pretty limited. Actually, we have no universally protected vaccine available. There is only one commercial vaccine, which is based on whole cell inactivated strain, which is named abactedin. But this commercial vaccine or commercial bactedin has a very limited geographical coverage and use. So disease control is based mainly in two approaches: antimicrobial prophylaxis, as we already discussed a few minutes ago, where allowed, and mainly by the use of autogenous vaccine. What is an autogenous vaccine? It's a bacterin that is made from the strain causing clinical signs in the herd or in the farm. Then the strain is isolated. It's sent to a laboratory authorized to prepare autogenous vaccines. And then the vaccine is prepared and sent back and applied to the farm, the same farm where the strain was isolated. So we will say that an autogenous vaccine is a farm-specific kill bacterin. What about the efficacy of autogenous vaccine? We have been working a lot in trying to understand the protection conferred by the autogenous vaccines, and our results are controversial. And the reason is that the efficacy of the autogenous vaccine will be affected by how the vaccine is manufacturing, the procedures that are being used to culture the bacteria, prepare the heat kill bacteria, the bacteria concentration in the vaccine formulation, the formulation itself, especially the adjuvant used to prepare the vaccine. So you have a lot of variables affecting the efficacy or the protection conferred by an autogenous vaccine program applied to a farm. So what will be the recommendation? It will be recommended to veterinarians to inform themselves how the vaccine is prepared, how the vaccine is formulated prior to introduce the vaccination program in the farm. That would be my advice based on our scientific data.
Okay. And like it sounds like if you're making vaccines specifically for like one farm, which is different from a different farm, I imagine that means that the costs increase. Would that be correct?
I mean, the cost of the vaccine will be affected by, I guess, the number of doses that they will be ordered for to be used in the farm, the concentration of the bacteria, and the number of bacterial strain introduced into the vaccine, but not necessarily because one farm order a vaccine and another farm order a different vaccine. Is the price is focused in the content of the bottle, we will say like this. So in some cases, you will have an autogenous vaccine prepared with only one bacterial strain, but in other cases, you may have 4, 5, 6 different strains that may affect the price of the final product.
Okay, that is good to know. So then, like, can we talk a little bit about like some innovative approaches? Like, are there any new promising vaccine technologies that are being explored for Streptococcus suis?
Okay, now we will be discussing research approach, which means they are not commercially available and they are being explored by different research groups in the world. So there are three major types of vaccines under experimental conditions. The first one is still, we keep working on trying to improve bacterians, I mean the heat kill bacteria, working on the formulation, how to prepare it, how to use it, what is the best vaccination program to be used. The second is live attenuated vaccines, but we discussed earlier that the Strep suis is a zoonotic pathogen. So we don't know if a live attenuated vaccine is attenuated in pigs, but will be attenuated in humans. So if the vaccine strain is transmitted to a veterinarian, for example, it could be a risk. So live attenuated vaccine pose a human public health concern about potential risk for those manipulating the vaccine. So we don't believe, I personally don't believe that will be a market for that until we can really prove that it's safe for humans. And the most of the research focus on subunit vaccines. And there are two approaches, those working on proteins that are exposed at the surface of the bacterial pathogen. But one of the difficulties in terms of getting a good subunit vaccine based on proteins is they identify a common protein present in most virulent strains in different parts of the world due to the high variability we mentioned earlier. But there are some good candidates there, and luckily we will reach those candidates will reach the market in the next future. We don't know when, but the research is moving fast on those areas. Another innovative approach, my team has been working since the last 6, 7 years, is working on the sugar coat of the bacteria because it's more exposed antigen at the bacterial surface. And we were really working to produce a synthetic antigen uh, of this capsular coat that can be then conjugated to a carrier protein, a concept that is called glycoconjugate vaccine, which is a concept that is being used in human medicine to fight meningitis and septicemia in children. So it's innovative approach in veterinary medicine, but have been used and proved to be very efficient in human medicine. So we are trying to make this new vaccine with this new innovative approach and see if by using this approach we can also get a vaccine at low cost to be used in swine.
Okay, so there's some great things that are coming up in hopefully a couple of years' time.
Hopefully.
Yeah. So in the meantime, like, what are the key factors influencing the adoption of like the current S. suis vaccines by pig producers, and how can researchers address like concerns related to things like cost, efficacy, and implementation?
Okay, so for any experimental vaccine that will be that will reach the market, the cost of the vaccine is a major issue for swine producer, of course, but also the ease of administration and the efficacy proven under field conditions. So sometimes a vaccine will be very good in preclinical trial, but then in the field situation, things can be more complicated. So one of the, I will say, the challenges in terms of adoption by the industry is also what is the best vaccination program, or do we need to vaccinate sows or do we need to vaccinate piglets? So ideally, vaccinating sows would be the most cost efficient approach for swine producers. So we will increase the level of antibodies in the sows and then the transfer of those maternal antibodies to the piglets via colostrum. But one of the challenge, and we have some data on that, is how long those maternal derived antibodies will last in the piglets to cover all the nursery period. So we have some data that at best, when using autogenous vaccines, that the antibodies will last until 4 or 5 weeks of age in the piglets. And we mentioned earlier that the affected piglets are from 4 to 9 weeks of age. So we have these older piglets, post-weaned piglets, but older, that will not be protected during the second phase of the nursery. So, and we have another challenge in terms of sow vaccination is heterogeneous colostrum intake by the piglets. So even if we have very high level of maternal antibodies in the colostrum, we have piglets that take a lot of colostrum, but some other piglets will take a lot less. So they will have little or no maternal antibodies. So even if you have a very good vaccine applied to sows, doesn't mean that maternal antibodies will reach the piglet. So that's one challenge, and we'll keep studying those aspects of maternal antibody transfer from sows to piglets. Now, piglet vaccination, more costly, more difficult to implement, but maybe will be the only way to cover all the nursery period to protect Streptococcus suis against Streptococcus suis. Still, we need to do more studies on the possible interference between active vaccination and the presence of maternal antibodies in young piglets if we want to really get the vaccine working when actively vaccinating young piglets. And we have data coming out soon, not yet published, and we will keep working on those aspects because they are extremely important questions that need to be answered before a new vaccine can be implemented correctly in the field.
Yes, that makes sense. And like I'm thinking about like the piglets that are getting less of the colostrum are often the smaller ones that are not as able to compete for the good teeth. And those might actually be the piglets that need it the most because they might already be more susceptible to diseases. So I can see that as a challenge.
Absolutely.
Yes. Okay. So then, like switching gears a little bit, like can we talk a little bit about future perspectives? So, what do you see as the most promising strategies for improving S. suis vaccine development and implementation in the next, say, decade?
Well, we need more research for sure, and we need to focus not only in the antigen itself to be put in the vaccine, but as I mentioned, interference with maternal antibodies if we want to implement an active vaccination program in piglets, and we need to find candidates that are present in most virulent strains, so from different parts of the world, if we want to really target an universal vaccine. And I will say the main challenge is to get a very good adjuvant in the vaccine formulation. Adjuvant is the component of the vaccine that allows to intensify the response to the vaccine by the immune system and allow the immune system to respond in the best way possible to this vaccination. And in the case of Strep suis, the adjuvant is extremely important as the component in the vaccine formulation. I will say as important as the antigen itself. And we need more research on adjuvants to be used in Streptococcus suis vaccines. And I guess those are the future areas of research that we need to focus as researchers.
Okay, so you've got your work cut out for you.
It's time for our famous three. Fumonisins are one of the most prevalent mycotoxins in North America and can impact the performance of your feed and your pigs. MycoFix Fumezyme is the first ever CFIA-approved purified enzyme to specifically and irreversibly degrade fumonisins into non-toxic metabolites. Protect your pigs from fumonisins with MycoFix Fumezyme. Learn more at dsmfirmenich.com/mycofix. That's dsm-firmenich.com/mycofix.
All right. Well, thank you so much for introducing me anyway to like some of the work that you've been doing, and like hopefully our listeners learned a little bit as well. So to our listeners, if you are enjoying this episode, remember to like, subscribe, and share it with your friends and family. So then we're ready for the final 3 questions. So the first one is, what is your favorite swine-related book or resource?
Well, I guess that everybody knows it. It's a disease of swine, and it's an amazing book. And actually, I'm glad to participate to one of the chapters. But besides that, it's a great book, and we should keep producing the book and contributing to the book every edition. And I recommend to read the book.
Okay, perfect. I'll check it out. And then, do you also have a favorite book or research outside of agriculture?
Actually, I'm very fascinated about design. So it's very, very different from research and veterinary medicine. So I love all resources related to interior design, and I'm a fan of minimalist design and decoration. So I love the books from Frida Ramsten. She's a Scandinavian designer, so I recommend, if you like design, to read the books from Frida.
Okay, excellent. Thank you. And then the last question is, in your opinion, what sets successful swine professionals apart from those that are not?
Well, professionals, I guess for me, you need to be successful in your professional life is whatever it is, the area of expertise is leadership, curiosity, and collaborative work. Today things have changed a lot. Technology advanced extremely fast. So if you need to keep your knowledge up to date and to be a good professional, you need to understand a lot of areas. So collaborative work, working with different experts from different areas, they help you to be a good professional in whatever is your area of expertise.
Yeah, that I totally agree with that. Like currently, I think there's not a lot of people that can truly say that they don't work in a team, right? That
That's right.
Yeah. So teamwork, very important. So perfect. Well, thank you very much for enlightening us today and for being on the show.
Well, thanks to you for the kind invitation. It was really a pleasure to be here.
All right, perfect. So thanks everyone for joining us today. Don't forget to subscribe to our podcast to stay updated on future episodes. So that's it for today, and we'll see you next time.